All right, welcome to Chapter 3, Section 2. Still doing algebraic methods to solve linear systems. In this example, we're going to be doing, well, in this video, we're going to be doing problems 6, 7, 8, and 9, solving using elimination. And like I said in the previous video, always do what the directions are telling you to do. So you may look at a couple of these and say, hey, it'd be easier to do a different method. And the directions say use elimination. So even if you get the solution using a different method, you're not actually showing me you know the elimination method or whatever method it's asking for. And as I said when I first introduced this, later in pre-calculus actually, I wish we did matrices. Matrices is one of my favorite things. But later in pre-calculus, you'll learn how to solve these systems using matrices. So you'll have basically what we call a bunch of tools, all right? So it's kind of like, you know, a bunch of different tools in your toolbox. And you can then judge which method you're going to use for which problem shows up when you are able to give your own or make your own choice. But in this, we're going to use elimination. All right, so I'm going to look at this. I know that I want to add the first equation to the second equation. If I add the positive y to the negative y, I get 0y. That's the eliminating part. That's why it's called elimination. So the y's are going to get eliminated. I don't like the word cancel or dropped out or anything. Sometimes I might slip and still say it because it's a forced habit, but it's a bad habit. I don't want to say that. So what I'm going to do is I'm going to add these two equations. 2x plus negative 5x is negative 3x. Y plus negative y is 0y. And 12 plus negative 33 is what? Negative 21? Yeah. That's right. Sorry, it just didn't look right. Hang on a second. I don't know why this is bugging me. 12 minus 33. I don't know why that was bugging me. It's just, it's like I think I said this earlier. Sometimes you just look at like a word and you know you spelled it right, but it just doesn't look right. Sometimes that happens to me. All right, and if it happens to you too, that's just perfectly normal. I had to double check. All right. I'm going to divide both sides by negative 3, and I get x equals positive 7. So there's my first solution. Now, in the previous video, I talked about doing your check. You can check this by substituting 7 into both of these, and if you get the same y value, that means you did it okay, all right? So that's one nice thing about elimination, is that by doing the substitution into both equations, if you get the same answer for the other variable, in this case the y, then you know you did it right. So my first equation is 2x plus y equals 12. And I think the book says to just go back and do what the substitution does, which is check it using a T-bar organizer. But this method works. I like showing both methods. Okay, this is 2 times 7 plus y equals 12. That's 14. And if I subtract 14 from both sides, I get y equals negative 2. So I think my solution is 7, negative 2. Let's do the other one. Negative 5x minus y equals negative 33. Negative 5 times 7 minus y equals negative 33. This is negative 35. And if I add 35 to both sides, I get negative y equals positive 2. And of course y is still going to be negative 2. So since I got the same thing in both of them, I know I've got the correct answer. So my solution is 7, negative 2. Let's look at problem number 7. Again, this is set up nice for us. The 2x and the negative 2x, those are going to be eliminated when I add them. 2x minus 2x is 0. So I'm going to draw my summation line there. I get 0, negative 5y plus 8y is positive 3y. And negative 5 plus negative 58 is negative 63. And if I divide both sides by 3, I get y equals negative 21. Don't panic if it's a 2-digit number. It's okay. They don't even have to be whole numbers or integers. They can be fractions. That'll be all right. So let's start with this one. 2x minus 5y equals negative 5. 2x minus 5 times negative 21 equals negative 5. Negative 5 times negative 21 is positive 105. And I'm going to subtract 105 from both sides. And that's going to be negative 110. Divide by 2, and I get x equals negative 55. Let's try it with the other one. Negative 2x plus 8y equals negative 58. My y is negative 21, so I do negative 2x plus 8 times negative 21 equals negative 58. 8 times 21 is 168. Positive times negative is negative, so negative 168 equals negative 58. I'm going to add 168 to both sides, and I get negative 2x equals positive 110. Divide both sides by negative 2, and I still get x equals negative 55. So my solution, xy, equals negative 55, negative 21. All right. Okay, so for problem number 8, notice that I do not have coefficients that are opposite. I got 2x and 5x. I can make the x's drop out. There I am, I use the word drop out. I can make the x's drop out. I can multiply the top by 5, I can multiply the bottom by 2, and I can choose one of them to be negative. I didn't mention this in the previous video, but some teachers do a subtraction, because sometimes they call it the add-subtract method. That causes more problems than it helps. So I just straight up say, if you're going to multiply and you want things to be opposite, you're not going to subtract, just multiply by a negative, all right? So if I multiplied here by 5, I get 10x, and if I multiplied this equation by negative 2, I get negative 10x. That'll drop out, okay? There, I did it. See, I said it's a bad habit. But notice that I've already got a positive and negative here. That's nice. And notice that all I got to do is, if I multiply the 3 times 2, I'm going to get a 6. So instead of multiplying both of them, I can just multiply this equation by 2. Multiply by 2. So it saves me a little bit of time. It doesn't matter in the long run, because you're going to end up not changing anything. It'll be okay. But I'm going to do this. So I got 2x plus 6y equals negative 8. I left that one alone. 5 times 2 is 10, so I get 10x. Negative 3 times 2 is negative 6y. And 2 times 88, that is 196. Okay, so now I'm going to add these together. 2 plus 10 is 12x. 6 plus negative 6 is 0. And negative 8 plus 196 should be 188. Positive 188. Think of it as 196 subtract 8. All right. Divide both sides by 12. And I think I can do that in my head, but to be honest, it's late. I'm not confident in my abilities. Divided by 12. Oops, wonder if I did something. 196 subtract 8. Yeah, I got 188. How about 88 times 2? Did I do that right? That's what I did wrong. It's 176. Okay. So now it's 1. See, I know it's late. I gotta check my work. This is why you always check your work, kids. So it's 176 plus negative 8, which now gives me 168. That's a 6. All right. That's why you don't use Sharpies either. 168 divided by 12. And I'm going to divide that by 12. Oh, that's nice. Now, there's nothing wrong with getting a decimal. I get x equals 14. Okay, so now I'm going to put this into both of them. People say plug. You're going to plug it in. That's another bad habit. 2 times 14 plus 6 times y equals negative 8. 28 plus 6y equals negative 8. I'm going to subtract 28 from both sides. I get 6y equals negative 36, and y equals negative 6. Let's check with the other one. 5 times x, which is 14, subtract 3 times y, equals 88. Remember, always go back to the original. This is 70. I'm going to subtract 70 from both sides. I get negative 3y equals 18, and divide by negative 3, and I get y equals negative 6. So that's the same. So my solution is going to be x equals 14, y equals negative 6. Arithmetic, I know. I can teach you pre-calculus and calculus. It's the arithmetic that's throwing me off. That's what I get for trying to do it in my head. All right, last one. So let's compare. I get the 1/2. Don't panic about the 1/2. I'm probably going to multiply it by something. If I was going to do something here, what would I multiply it 1/2 by to get negative 2? That's easy, all right? But if I look at the y's, there's a y, just one y. So if I multiply this by 2, then add it to the negative 2, that's going to eliminate the y's. So I'm going to multiply this equation by 2. 2 times 1/2 is just 1, so I get 1x. 2 times y is 2y, and 2 times 4 is 8. And again, like I said, don't put parentheses around the entire equation. You never saw me do that. I even said don't do it. All right? And don't let your teachers do it either. It's bad. The other one I'm going to leave alone. I get negative 2x, subtract 2y equals negative 6. 1 minus 2 is negative 1. 2 minus 2 is 0. And 8 minus 6 equals 2. So the opposite of x equals 2. You can multiply both sides by negative 1. You can divide both sides by negative 1. Either way, you're going to get x equals negative 2. Now let's check. I get 1/2 of x, which is negative 2, plus my y equals 4. Half of negative 2 is negative 1. Add 1 to both sides, I get y equals 5. Excuse me. Let's try the other one. Hopefully I got room. Negative 2 times x, which is negative 2, subtract 2, there's a lot of negative 2's there, y equals negative 6. This is 4 subtract 2y equals negative 6. I'm going to subtract 4 from both sides. I get negative 2y equals negative 10. Divide by negative 2 and I get y equals 5 one more time. So my x and my y are equal to negative 2 and 5. Okay, we'll see you in the next video.